Welcome back, ladies and gentlemen. Today we're going to be working on dividing numbers in scientific notation, so let's get right to it. So we have to remember a few things. We have to remember our fraction rules. How do we multiply fractions? What exactly that's like. And that's because this is the same thing as saying 1.5 times 10 to the negative 8th and 6 times 10 to the positive 7th. So we can rewrite that as 1.5 over 6 times 10 to the negative 8th over 10 to the positive 7th. The reason we can do that is because we are multiplying. It's the same thing as multiplying straight across as fractions, so we can actually separate the left side from the right side, because to make one large fraction, it can be two separate fractions through multiplication. That's only because we are multiplying right here. If we weren't multiplying, that wouldn't work. But using our rules of multiplying fractions sure does help us out, because 1.5 divided by 6 is going to be 1.5 divided by 6, 0.25. Times. Now here we should remember our rules for dividing with like bases, different exponents. We're going to keep our base, and then we're going to subtract. Well, that means we get 0.25 times 10 negative 8 minus 7. So we're going to move 8 times to the left, and move 7 times to the left, and we get a negative 15. However, we don't have a final answer, and I hope you've already spotted what exactly is wrong. I'll give you a few moments longer. If you said that our factor is not between 1 and 10, including 1, then you would be correct. What we have to do is we have to move that decimal one more time to get 2.5. So that's the same thing as saying 2.5 times. Remember, this dot right here means the same thing as multiplication, and in scientific notation is one of those exceptions that we get to have, where we can actually still use x as a multiplication symbol, specifically in scientific notation, and a few other exceptions. So here, because we moved it one time to the right, we actually made it bigger. We have negative 15. We moved it once to the right, so we have to actually, we moved it once to the right, so we made our number smaller here, from 25 to 2.5. So you have to look at it in terms of decimal. There was a 25, we made it smaller by making it 2.5, and so we're going to subtract 1 because that was one movement, and we get 2.5 times negative 15 minus 1, which is 10 to the negative 16. And here is our final answer. So let's go ahead and work through this as well. This would be the same thing as 0.1, 2, 3, 4, 5, 6, 7, 1, 5 divided by 6 and 7. 1, 2, 3, 4, 5, 6, 7. Okay, so our numerator is actually rewritten as 15 over 1, 2, 3, 4, 5, 6, 7. So 10, 100, 1,000, 10,000, 100,000, million, 10 million. One more, and you get 100 million. And all of that is going to be divided by 1, 2, 3, 4, 5, 6, 7. Well, I know in division those are going to cancel, so really this is 15 over 10 divided by 6. Now remember, those don't actually go away, but this is how to visualize how I can do this. So that's the same idea as multiplying by 1/6. So now I'm going to get 15 over 60, which is equal to 1/4, which is what we got here. The problem is now I have to put these zeros back in, so now I can take 1/4 or 0.25, because I need scientific notation, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, and 15. Almost forgot about this guy. So there's 15. Now remember, this was smaller, so if I divide a decimal by a whole, it's actually going to make it smaller. And then, if you notice, here is where I actually have the same answer. So this is the same answer as this guy. So I'm going to kind of fast forward. Since these two are equal, everything I did after works the same. So a final answer has got to be this guy, because this also has to hold true. Now I'm not going to double all my work so you can see it, plus I ran out of frame room, but I want you to see that since this 0.25 times 10 to the negative 15th is the same thing as 0.25 times 10 to the negative 15th, I can just follow the same steps, and as long as these are true, these were right, these were correct, I'm going to end up with the same answer from here or from here, because they are the same. It's kind of where they intersect. So as a refresher, when you see me cancel these out, this is just how I can think about it. That's how I got the 0.25, but I didn't actually cancel all of these, because this is what, 100 million, and this is what, 1, 2, 3, 4, 5, 6 million. But they're going to multiply. Remember, this 10 and this 6 actually multiplied, which means I'm actually taking this 0.25 and I'm taking the 15 and dividing them not by 60, but by 10 million times 6 million, or 100 million times 6 million. And that's why we got such a large or small number, because it's 15 divided by 100 million and 6 million. No, 60 million. I keep saying 6, it's 60. So if we count the zeros, there's 15 total zeros. Those would add up, and that's how many should be down here. We already had one, blah, 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 and that's how this would work by hand. Oh my goodness, I don't want to do this. We think this would be easier. We could also try to punch it into our calculator. Let's watch this. 0.0000000015. I don't even have enough room. If you can see it, the calculator does not have the number I just punched in. Divided by 6000000. It's going to tell me 0, but that's not a correct answer. I obviously get something else. So these calculators don't even work on this. You would need a scientific calculator, or even possibly a graphing calculator, to be able to get an answer. And even then, it's going to give you the answer in scientific notation, because it can't even show you enough decimal places, because our screen is limited. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Last, ladies and gentlemen, when you're learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.